So we're saying if the null hypothesis were true, which was that there is no relationship, then we would get these numbers here. Okay? Exactly. Now, what is the likelihood of getting these numbers here, or worse, or more different from what we're expecting, if the null hypothesis is true? And this is what the chi-squared test does. So everybody's going to call it a chi test. I know you are, because there's a drink called chi. But it's not. Okay? This thing here is a chi. It is the Greek letter chi. It's actually a chi, but we'll just go with chi, as in K-A-I, like Māori food. Okay? And it's actually a chi-squared. But they didn't want to call it that in Excel, so they call it a chi test. But they don't call it a chi test, or not in front of me, they don't. Okay, so what it does, which is very kind of it, is that it takes these, compares them, and finds the p-value. Now, our p-value here that comes in, you'll see my formula there. So notice I do not use the totals in my ranges, just the actual values. Okay, and then it says ZE minus 0.05, so that's the same as 0.0007. Remember, we learnt that earlier in the year. So we reject the null hypothesis. P is low, null must go. And so as a result, we say the proportions are not the same. The null hypothesis was that they are the same, but we're saying that these numbers are too far away from this to have happened by chance, so it looks as if there is a relationship between whether a person is male or female and whether they own a car or not.